Okay, I just started the recording. This is the meeting of the Kubernetes IoT and Edge working group. These meetings are public and recorded and will be uploaded and available on YouTube. We already started this and missed a little bit. We have no agenda today, but the three of us are showing up, are just having a conversation on trends and thoughts on what's going on in the field of IoT and Edge. Yeah, so go back and continue with your thoughts, Moritz.
Yes, as I said, I just had a really interesting talk yesterday with a colleague that he was actually like managing edge devices with operators, like Kubernetes operators and CRDs. And the interesting idea he came up with is that basically Kubernetes is allowing you to kind of build your system in a model view, and then you just hand this model over to your cluster, and your cluster kind of connects your model to the real world. So it kind of creates this digital representation of an edge device or of a state that you want to run your edge in. And that's actually something like a lot of different other techniques, like for example UML and other modeling techniques are trying to solve, like connecting this model view aspect with your real world. But it often diverges because I don't know who actually uses UML, for example, but it's really hard to like keep your real world application in sync with your model. And Kubernetes kind of bridges that, you know what I mean? So,
right. Yeah, I think my experience in software with UML is, first of all, there's a lot of religious zealots who take it too far and burn up all their runway doing UML diagrams without building anything. Waterfall thing, exactly. And run out of money before anything useful gets built. Then even if they build it, you discover as you go along incrementally what you did wrong and some invalid assumptions. But people never go back and update the UML to match the actual code. So ultimately it becomes potentially harmful for newcomers who assume it's correct when it no longer is, and not a big fan of it myself, based on theoretically it sounds good, but I've seen more projects killed by it than I've seen helped.
Oh, wow. Okay, I didn't know it was that serious.
I think it has its usefulness when you can use it to get ideas out and figure out the
design phase.
Figure out the gotchas in the architecture before you build. But Steve, I've seen what you're talking about too, and it's absolutely true. That's the first thing to get out of date with the real world software. It's a big danger. So therefore, the more accurate you try to make it, the more likely it is to break down.
Yeah. And I'm not a zealot against it either. I mean, there's validity in having standardized diagrams and drawings so that everybody can understand what you're portraying rather than inventing from scratch on every new project. But that said, I think the real interesting thing about Kubernetes, with its architectural model of having an API where you state a desired goal or condition and then have these control loops in background relentlessly attempting to achieve it, is really something that's been used in the IoT field for decades, for what is often called supervisory control, where you've had something like a tiering of low-level controllers. Things, in the US, they're called loop controllers or temperature controllers, PLCs, and then a secondary tier that often, downloads set points to these things, but it's designed so that you can sever communications to this lower tier, and they still go on attempting to achieve their last known settings of desired goals. And it's something that's known and proven to scale and also be resilient in the face of failures of isolated parts of the system and failures in communication. And that Kubernetes model can be used to do that for any number of problems. Initially, it was for containerized workloads and cloud data centers, but actually moving that down to IoT and edge isn't unlike a lot of legacy technology that has already been built up for decades. It's just that I don't think people approached it with a clean architecture. So these things, just from natural selection, if you will, kind of evolved to look a lot like Kubernetes, even though people might not have set out with that as a plan when they started to build it. And the effort of taking a lot of this legacy stuff and putting the Kubernetes control plane facade on it, I don't think would be that difficult. And the whole controller model in CRDs in Kubernetes means that in many cases, I don't think you even have to rebuild from scratch. You have to take your time to architect decent custom resources, but then the actual code and the operators could simply call existing legacy projects to do the implementation, or, that's my belief.
I think it's right on the money, because you actually have a lot of work that's been done to figure out what should happen at the low level, and oftentimes you have a break in the status reporting and the frequencies and things, right? Some things only happen in edge environments very slowly, and some happen very rapidly, and in no case should you try to set a standard tempo. So what you can do is you can use custom resources, you can use all of the centralized stuff to drive it, but then you just make an interpretive layer, and that handles all of the nuances of the particular situation. Maybe you need to query parameters actively, and you're used to getting status reported. So something does that and it looks native. And then it's really all about making interpreters, right? And that's a very scalable model, especially when you can reuse code.
Yeah. Yeah, there's any number of these interesting projects in the edge IoT space, like the what is that project that does the device twins and things? And I think some of them already seem to have work going to Kubernetesize them, but others don't. But I think the CRD model is flexible enough that you could apply it to most of the things.
Yeah, in fact, like what I often see is that people are taking some of these, especially like Eclipse IoT projects, many of which were made for particular scenarios of device management or firmware updates and this type of stuff. And you can deploy it out with the Kubernetes infrastructure, right? So how does that even get stood up at the edge? And that's stuff that, of course, we look at with like IOFOG. But yeah, it's interesting because you have a lot of efforts to handle, RTOS environments, and then to handle device communication where you're pulling stuff off of serial ports, and then you want to standardize it, and then there's digital twinning and all of this stuff. You put it together and you really probably have most of the pieces that you need with a couple of glue and sandwich layers, right? And you don't have to write so much, I don't think, in order to achieve most results.
Yeah, it seems like the three of us are in agreement, and I think it's a fascinating opportunity. We just need the framework to go build this stuff and convince and enlist our army of followers.
Well, I think the biggest trick, at least what I see happening at the edge next, is defining, standardizing the openings that can be used for common relay of actual data and device attributes and information. And I don't know exactly what form it's going to take, but I personally believe that something like Moritz, you're describing a modeling, right? So what is the language that was used to do the modeling? Was it a YAML file, or what was used to actually set up those models?
I think they're kind of seeing the custom resources or the definition of the replication not a replication controller, like the YAML file you hand into your cluster as a modeling language. So,
okay, gotcha. Yeah. Okay.
Of course, you can go a step up and say, okay, we now build a modeling language like UML for that, and kind of translate it. to make it a little bit more human friendly. But in that case, I would already say that we have quite a good modeling language because YAML is quite easy to read. So
yeah, there you go. Yeah, that if you can define the structure
yeah.
of what a device is supposed to look like in terms of how it maps, then that's I think one of the trickiest parts is just finding a universal way to describe anything that can interface, and then that means that the building out of those interpreters is not so difficult anymore. It's just mapping.
Yeah, exactly.
Yeah, I think Kubernetes already has a nice model. You know, when you look at devices found out at edge and in the IoT space, you know, they're going to have things like firmware versions that maybe are akin to versions of a container image, and they're going to have things like configuration that are akin to things you try to do with container-based apps. And I think you should be able to manipulate those with code and controllers to handle things like doing firmware updates on devices that aren't even traditional computers and aren't really container images.
Yep, and calling functions on them, right, to do things at the edge that are probably related just to that device, but if properly labeled, should be callable just like any other, updating any other attribute.
Yeah, and then in terms of the things they run after you get beyond the firmware updates, you know, there are things like programmable controllers that have ladder logic diagrams or compiled ladder logic diagrams that are downloaded to them. And those could be delivered like container images. The other interesting opportunity here is, I think, a step above them, managing the network infrastructure and communication protocols is somewhat akin to Istio, although they're probably using non-TCP Istio was optimized, I believe, for layer 7 HTTP based TCP, and you're going to want to do something similar of a central control plane with observability to manage the myriad of industrial and edge appropriate protocols. But that's a big problem that needs solving too. And I think you can use the model that was used initially for Kubernetes cloud data centers out at edge.
Yep. Yeah, it makes perfect sense. And it's interesting because oftentimes too, you need to translate, you know, from one protocol to another, receive data which is just byte ordered, right? And something has to slice it up and translate it. And then you have, after that, usually data in a state that you can consider universal, right? You've got keys and values. And it's your choice whether you want to send that up toward the, you know, via TCP/IP and send it up to an HTTP receiving system, maybe a REST API, or whether you want to keep it down there at the edge and put it back out over MQTT, or whether you want to put it over the serial line. So it really isn't a matter of fixed network translation. I've always thought you can't have like a hardware gateway layer that translates between, you know, protocols used at the edge and then TCP/IP and HTTP layer 7 stuff. It's just, there's going to be too many variables. What happens out there? You need a little bit of intelligence there to do it right, in my opinion.
Yeah, not just convert it to TCP, wash your hands, and say you're done.
There were some attempts to do that with Bluetooth Low Energy, basically report, you know, things in a certain structure up to REST APIs or over TCP/IP, so you can convert Bluetooth data, you know, signals to Wi-Fi data signals, and then pick them up on a server on the LAN or something. And to the best of my knowledge, you know, only the demo devices that came with those gateways really functioned, and nothing else really worked, because you have to establish a session, right? It's just a totally different model of networking.
Yeah, and I think some of the reasons those proprietary, very specialized hardware-based transports exist is they have very unique requirements that don't map, you know, to L2 Ethernet, and they never will. And, you know, trying to determine that you always have to convert to be able to manipulate them just seems wrong. That you need a management layer to manage those specialized networks based on specialized transport, and leave them the way they are. Simply take on the management and observability.
Yep. Completely.
Well, I think like
good use of edge computing. Sorry, go ahead, Moritz.
I think one of the biggest problems with all these different protocols, I know what you're talking about, because especially in manufacturing, like we have a lot of these proprietary protocols that try to kind of do the management on your own instead of like they want to kind of keep them in your system instead of saying, okay, we want you to use different protocols, you know, like Profibus, for example, tries to keep everything together, and they implement the management plane themselves. And I think that's one of the biggest problems right now, that everybody is doing his own thing, and instead of just like coming together and like creating one control plane that can handle it all.
Yeah, the walled garden business model, right? Which used to be a great business model, but until open source ate the world.
Yeah, even a lot of those protocols, I mean, unless a vendor was really dominant, I think the customers voted to go with things that were a little more open standard with multiple vendor support.
Yep, there's over 1,500 protocols. Well, I mean, Steve, you know this from your past, right? There's over 1,500 protocols in the industrial and what is now called IoT space, and there's a top 20 or so that are everywhere, and the rest of them trail off depending on which vertical you're in and which vendors.
Yeah, I think for industrial control, I'd even go on, if you want to be a big player, you might have to go well above the top 10 into 40 to 60. But then if you get into other specialized niches like automotive, I mean, there's potential here. Just look at the number of buses. If you, I don't know, I'm a, hobbyist mechanic and work on my own car. But if you even look at the different buses connected up to your OBD2 port, there's potentially, I believe, 10 of those. Not every one of them is in every car, but there are a lot of them.
Yep. It's actually, there's some really great OBD2 port Bluetooth low energy modules that you can get. It's hard to find one that's got the right configuration. A lot of them are Bluetooth, but not Bluetooth low energy, which means that, you've got to establish a session with your iPhone or your Android phone. But anyway, you plug it in and then you can just query it as if it was a serial port and pull the data out. And you can do that with a Raspberry Pi or even a Raspberry Pi Zero. So we're talking $50, $60 of compute hardware, and then all you need is an adapter for your lighter jack in your car, or you could use, if you got a modern car, a USB port, and now you've got edge computing and you can talk to the vehicle just like that.
Yeah. I've got one of those for mine, and it does most of those protocols, but I mean, I found looking into it that the anti-lock brakes might be on one. You've got really low-end I2C stuff routed there for other things like entertainment buses, door and window access control, security. I was shocked at how many were in there, even in a car that's 5 years old.
Yeah, it's a little scary too, especially there's, you can clear the flag for the check engine, and so just, I mean, that's a convenient way to get that to turn off, and you don't want it off.
Yeah. Well, I was surprised because those consumer OBD2 readers just show you the surface part of the iceberg. And when you look at these specialized ones that are required to do firmware updates on the modules and things, that's when you really discover how many of these protocols are there.
Oh, yeah.
On certain vehicles, you have to route through one of the more common ones to get to the other buses, but they often have ways to do that. Sometimes they're documented, sometimes they've been reverse engineered, and it requires 30 minutes of Google search to figure out how it works. But
wow.
It's out there.
That's the deep stuff. Yeah, cool.
But anyway, the bottom line is, I think that mapping out all of these protocols that are edge and IoT, you're going to find that you really need a solution that takes plugins. If you wanted to attempt to do the control plane for these, whether it's Kubernetes or something like an Istio that is non-Kubernetes but works with Kubernetes, you'd best develop it so that it was extensible.
Oh yeah, yeah. That's the only approach that's going to work. Things change too fast, and you'll never incorporate all of that that's out there. There's an interesting project at the Eclipse Foundation that's getting more and more attention, which is a Spark plug, and there's a working group forming around it. One of the original creators of the MQTT protocol is heading it up. His name's Arlen, and really amazing guy. And so the project is intending to put standard data definitions around MQTT messages, such that no matter what you get off of a device, if you're going to use MQTT as your backbone, you translate it into this final agreed upon format across verticals or companies in the same vertical, and you have some agreement such that doesn't matter how you implement it, but we finally have kind of a point of common data structure. And I think it's great. It's about time, especially because it rides on top of the open bytes of MQTT packets. It doesn't matter what you had in the past. If you write a little translator, you're still good to go.
Yeah, that'd be interesting. And I could see making devices talk in this new one, but another way of doing it that maybe brings legacy to the party would be to have sort of a brokerage receive everything and attempt to, manipulate them like a Kubernetes admission controller, where, something gets accepted and potentially modified and put into some kind of NoSQL database that would put these in a standardized form for people to consume.
Cool. Well, I'll add something to that then. There's a lot of information, context information relative to or related to the solution that you've got that needs to be added to the simple low-level data. If you've got some really dumb temperature sensors that are, or moisture sensors that are out for like smart agriculture, you're not going to time synchronize all of them. There's especially about 2,000 of them. What you really want is you want them to report their raw data and the timestamp and the identifier. You want to assign those on an upper layer, because you also don't want to take the, let's say it has something like a MAC address, right? Maybe it's on LoRaWAN or, something that has similar features to your MAC address that we're familiar with in the TCP IP networks on Ethernet. And so something similar to that, a unique identifier you can read. You're probably not going to know which one's which. So somewhere you've got a map, and you could assign a timestamp. You could use that map to assign contextual information like a label of which sensor it was. Maybe you have some geo coordinates for where it was placed, and all of this stuff is, when you think about it, a time or a temperature reading might be 4 bytes coming from the device, and you're sending this over. If you send it especially over like Bluetooth Low Energy or LoRaWAN or whatever, every byte really counts if you've got 5,000 of them.
Right. So you don't want to append all this information and maybe do it at another tier.
Exactly. Right. Plus you wouldn't even know, right? You don't want these sensors to need to be time synchronized or to know their unique solution identifier.
Yeah. Or to even have a GPS to know their location.
Yeah, exactly. So
so the other thing that I
data,
thought
but
about for these, and I don't know, I don't know that this is my idea, but I've thought about it, is this idea that you're going to have all this LTE5 delivered data, some of it with properly labeled, some not. But if you can take it to a higher tier that maybe has good clock synchronization, knows the location and appends to it, at some level, some of the stuff is sensitive enough that you even want to authenticate it so that it can't be tampered with later. Anything from security cameras, where some of these AIs are purported to be able to create false images that look authentic. But at some lower tier, if you could apply blockchain-like journaling, I'm not saying it's literally blockchain because there's some issues with that, but, put enough journaling on them that you're going to be able to detect somebody attempting to revise history by tampering with the data, and then feed it up with this intact, where you can authenticate that this is the actual reading from this location. I think there's potentially great value in that from a security context and even a resiliency context. I mean, when you have things like ransomware attempting to attack these things, there's no doubt they're going to be going after, if there's money to be made or even ransom to be made by messing with this stuff, making it ultra resilient has a lot of potential value.
Oh, I would say so. And in fact, this is probably the biggest challenge area for the edge. Will be graduating from the raw infrastructure into guarantees around the data. And if you're going to use it for automated commerce, then you have these challenges absolutely have to be solved. Imagine you have a supply chain integration, and at your warehouse you're receiving $2 million worth of components and on several pallets, and they come in and there's some readings taken not only for the contents of the box but the weight, and there's all types of stuff that you use to take measurement before you release the invoice payment. And you automatically decide that the shipment doesn't look complete, so you pass it, instead of settling that day, you pass it off for manual review, and it takes 10 days for someone to get around to looking at it because you no longer have people on the dock all the time. And the company that sent you the stuff needs that working capital, and now they're mad at you and they say, prove it. Well, who owns the data and who is able to determine that it's entered into an immutable state, and that information that was used to make a business transaction happen automatically or not happen automatically is still pure and was generated correctly, right? This is really important stuff for automating the world, which we're far from doing, but we are aiming that direction to have fewer manual checks and balances.
Right. Yeah, I think there's a lot of potential for things that are, say, gateway-like, where you take really low capability devices, and when they first hit a more capable gateway, you could append a lot of information, maybe attempt to make them tamper resistant, maybe even engage in feeding them up through redundant channels of communication. For example, some of these forecasts of LTE-5 are projecting, in a competitive world anyway, cheaper transports, so that maybe you'd go with multiple carriers for resiliency. If you're in an area where you could get 2 cell carriers or 3 or 4 that all could provide service, if it's cheap enough, maybe you go with 2 and reaching some gateway devices when you do that split to get the redundancy. I kind of think that these LTE-5 networks, the story will be they're ultra resilient, but that was the story in public clouds too. But it seems like every year, every public cloud provider has some outage of several hours in some region of the world. So the reality is different from the theory.
Yeah, well, also, when the abstraction reaches such a point that it's spread across almost all of the physical infrastructure available, it becomes equivalent to the physical infrastructure again, right? So there's only so much redundancy you can build into something that has failure points, inherent in its underlying hardware. But to your point about the edge and the edge communication and 5G. Yeah, it's like if I really could have reliable communication where it wasn't priced at the absolute limit of my willingness to pay, I would definitely throw redundancy in there, and I would start using it for more and more data pathways too. Right now, I try to conserve what I send over cellular because there's an expense associated with it.
Yeah.
Yeah.
In a way, I'm not sure that in reality, building into your hardware the ability to use 2 carriers might be a great insurance policy, right? I mean, if you look in the US, there's a lot of cell phones that only have a radio that is in the device that's unique to one of the carriers. But that's a lock-in. And once you get tens of thousands of them out there, they're going to know you can't go anywhere else and what's going to happen to you. But if you could build in the capability in your devices to use multiple carriers, whether you use them or not, you maybe have gained some financial leverage. And yeah, once they're in there, maybe you should actually use two if the resiliency really matters to you.
Yeah, there's also a big difference between these IoT devices and IoT gateways and, like, a smartphone. You don't go back out to the oil well at the pump head to change that gateway when you decide to change carriers, and therefore you really are locked in if you're on a single connectivity provider, because the sheer cost of going out and changing the hardware out or changing the radio module is just prohibitive. So I think it's an insurance policy for having available connectivity, and yeah, financial leverage for sure, which is that you've built in the rights to flip a switch and change over instead of needing to bear the physical change out cost.
So since we're freeform today, I one of the more interesting, I posted that interesting blog, but an interesting conference session I went to, which unfortunately, as far as I know, is not available publicly in a deck or recording. But at the VMworld conference, there was a talk put on by a couple guys from Accenture who were talking about the impacts of LTE5 and edge computing communication. And it was really fascinating in that one of the points they made is that people aren't generally aware of this, but they were predicting, and they claim that there's others who also have the same conclusion they shared, that LTE5 is going to have as big an impact on the world as the transition from dial-up modems over to broadband did. If you're old enough to remember those days of using those dial-up modems on landline phones, you really didn't know what you were in for when those things became obsolete and permanent connectivity to the internet became the norm rather than, this intermittent contact. And the LTE5, they were contending, is going to be as big a technology shift in terms of the use cases it enables, where whole businesses were essentially, I would contend, created that couldn't have been done without broadband internet. And people didn't even dream of what the possibilities were. Anyway, in their talk, they went on to quote another forecast from Gartner that was saying, if I'm remembering their data correctly, they were saying that there's been this tremendous trend of not necessarily applications moving, but new application workloads are being hosted in public clouds, and it's been one of the biggest growth sectors in technology. But that the edge enablement brought about with LTE5, among other technology factors, is going to start to create a scenario where the bulk of new workloads is going to be hosted out at edge. And I think their figure was that by the year 2022, 70% of new workloads were going to be edge hosted rather than, that could be edge or on-prem.
Yeah.
Versus public cloud. And if that's even partially true, that's pretty.
Exactly. It doesn't even have to be 100% true. Yeah, I certainly like that. I mean, given, from where I sit. But I mean, it's at least partially true. And I'd say, 50% true was wonderful. But when you think about it, there's a lot of advantages to what we get from the hosted cloud infrastructure. But at the edge, you're paying for your own electricity, you're paying for or have set up your connectivity, and you likely own the hardware. Those are a couple of things that you were paying for in the cloud hosted infrastructure. And if you have a workload that really doesn't need to be run centrally, all of these things already taken care of at the edge means you have very good scale economics for the amount of processing that you do. If you can keep up with the workload, it's incredibly cost effective. But all of that stuff became really hard to manage historically, and so we decided, centralizing was better. And at the time, I think that was right, and I think all of what we've got in the cloud is good.
Yeah.
But if it's
I think their definition of edge, and most people though entertain scenarios where it isn't necessarily you own it. They're classifying things run on, let's say, operator hardware, operator meaning internet carriers and telcos
Yeah.
that would host in cell phone towers, switching offices, as also being edge hosted.
Wow. Well, that's amazing. I mean, I hope that's the case. That'll be great. But yeah, I guess the business drivers are ones of latency. I don't know what the cost will look like, right? What will the spot pricing be for running a microservice, like, right at a cell tower versus running it in the public cloud? I'm not sure.
Yeah. Well, I think that a lot of these carriers think that maybe there's a business model there of running, call it a public cloud in a different way, where it isn't a centralized public cloud, it's an edge hosted public cloud.
Oh, I'd say definitely there's a business there. Definitely. In fact, it would, for a lot of carriers, it would change them over from being dumb pipes, right? I'm just going to move your data for you, to being an active service provider of compute infrastructure. That'd be a great transition for them. Normally they're just pathways.
Yeah. I mean, even look at the potential market there if you could host at edge and you owned certain sensors. Some people are going to have to put up the capital for these sensors. In a lot of these smart cities projects, they're owned by government entities. But I think in potentially others, there might be ways for privately owned collected data to be put there that is of value to other people other than the people who collected it, and they'd want to potentially use it out near the edge. Security cameras might be one like this. I believe in the US there are such things as privately owned cameras that are looking at things like freeway exchanges doing license plate scans.
Yeah.
And they aren't going to personally monetize those. They want to sell that information as a service. And there might be other opportunities like that to just put cameras on freeways and count vehicles. And it's strange, but one of the things that I pointed out in a talk I gave years ago on IoT are that you might think that counting the vehicles on a road is only of value if you're producing a traffic report. But in reality, that data could allow you to do a bunch of other things. I'm not saying it's the best way to do it, but for example, if I had the vehicle counts and speeds of every freeway in Los Angeles, I would contend I could give you a weather report. I mean, there are some things that happen when it rains, vehicles slow down in predictable patterns, that from vehicle sensors alone, I think I could probably give you a good idea, at least some weather conditions. I could give you readings on economic conditions. If I was able to count vehicles on roads, I might be able to identify what retailers are doing well and not so well.
Oh yes, that's actually there's business around that already, taking the security camera footage from parking lots and using it to sell back to retailers information about their own stores.
Mm-hmm.
Yeah, there was in the city of San Francisco, there was a project that came through this program called Startup in Residence, or STIR. It's a really amazing program, and the startup, I don't know what became of it, but it was a company called Birdie, and I think it was BIRDI. And up until this project came through in partnership with the city, there was, I think, just maybe three, maybe it was even one air quality sensor that was owned by the city that had been there for 20, 30 years. And its position was, up on, I think maybe it was even the same hill there, hill/mountain that's home of Twin Peaks and the the radio tower that's up there and stuff. So if you're going to take air quality measurements of the city of San Francisco, you want a lot of data points from a lot of different parts of the city, not a couple of huge chunks, but the cost of putting those sensors out and getting the communication back from them in earlier days was prohibitive. So you did it with, $10,000 sensor units, and you put out a few of them and you got what you needed. But then along comes a startup, and it asked people to put them in their window of their apartment or their home or whatever around the city. and then allow it to talk on their Wi-Fi. And in exchange for letting it ride over their Wi-Fi and sending the data back to the Birdie cloud or whatever it was, people got the air quality report. They basically gave these out to people or charged a low amount for them. And so now all of a sudden there's thousands of data points giving a much more accurate map of air quality in the city of San Francisco, the low points, the high points, the neighborhoods that are, still near whatever light manufacturing, I'm not even sure. And that's a really interesting, kind of example of what you're describing, which is that collectively we can provide a lot more data that's useful for mining or analysis or whatever. And in this case, it was purpose specific, but cameras can be used for so much.
Yeah. And in a lot of cases, I don't think you necessarily have to pay people to do it if it's cheap enough and there's either some model where they get some benefit out of having that sensor themselves, or, just want to join some big crowdsourced effort. And I know of two things like that. There's a weather company called Weather Underground that allows you to build a private, you can buy a private weather station or do your own and join their crowdsourced data network. And I go to Weather Underground. I think their forecasts are actually better than the National Weather Service, at least in urban areas. They have readings within blocks of my house, and they're really capable of showing microclimates, not one or two sensors for a large city like Los Angeles. And because of that density of data, I think that they've actually got advantages over some of the traditional data gathering situations already. There's another one called Flight Radar 24 that are using these new air traffic control transponders. I don't think they fully officially go on the air for another few years, but the old model was that control towers at airports used radar to spot incoming aviation, and the bigger airplanes would have tags broadcasting some kind of unique identifier. But the new ones involve point-to-point where the airplanes themselves are required to have a device that has GPS so they know their own position and just broadcast out the position. And a receiver at the airport then doesn't have to use radar to know where these things are if it can count on all of these having their own beacon saying, here's who I am and here's where I'm located. And it turns out that you can buy a receiver and antenna off Amazon now for about $45. And enough people have put these on the air in urban areas that there's very dense coverage. And this, if you're inspired to go look at this, go load a cell phone app called Flight Radar 24. And if you're in an urban area like me, you can sometimes hear a helicopter going overhead, and the thing will actually tell you what that is. And in many cases, even show you a picture of the vessel. And it's pretty impressive stuff for something driven entirely by crowdsourced data.
I'm downloading it right now. Thanks for the new hobby.
Same.
Yeah, you can, by the way, if you're on an airplane with Wi-Fi, you can run that app over the Wi-Fi and see your own plane and know where it is, probably with better accuracy than what some of those seat back things do. And you can actually see the other airplanes around you and spot when you're coming in near the airport. You can actually spot whether the airport appears to be running circular holding patterns by just watching it, because you get your own personal radar coming up on your device.
This is really amazing. I want to say that I've been shown something like this before in a web app. And what I'm looking at right now is just a whole host of planes around, I'm nearest to Oakland Airport. I live in Berkeley, and I want to say I've seen something like this before. I love it.
Yeah, it's remarkable that they have people go out and, once you know the tag number of an airplane, they try to get people to take a picture of it. so that I don't know what device you're on, but if you're on a tablet, you can actually see the picture of the aircraft and know whether, in my neighborhood, I want to know whether if I hear a helicopter hovering, if it's a traffic helicopter, I kind of know there might be an accident on the nearby freeway. But if it's a police copter, maybe I don't want to go outside if they're, chasing down somebody. And might be best to keep the doors locked and not go out there, if you know what I mean.
Yeah, or when I run from the law, I would definitely want to know if they're overhead.
That site, by the way, is somewhat controversial, I think, because because it's crowdsourced, and I think it's hosted in France. They've refused to mask planes. So some of the police vehicles in Air Force One don't actually they want to be invisible, but that database leaves them fully visible.
Yeah, well, there's information wants to be free, which is often misinterpreted as that it should be, without a price, but that's not the case. It's that it wants to be known. That is how very.
But anyway, as a principle, I think that there's potential with Edge and IoT for a lot of this private. It isn't just smart cities. I think there's potentially going to be a lot of privately generated information that is of value to other people. And if you ever ended up with this inverted cloud where the model is that operators are hosting compute capacity near where this data comes from, they might be in a position to also host access to this data, kind of maybe, like right now, if you do a YouTube video, Google will place ads on this and let you monetize it. Well, what if there was a business model where you could have this crowdsourced data, relay it to one of these operators, and if they could give you some vector where you get a fraction of a cent from anyone who'd ever use it, that might be interesting. And it might encourage people to be financially incentivized to be a source for this stuff.
Yeah, currently we have YouTube celebrities, and soon we'll have sensor and IoT data moguls. Yep, looks like we lost Moritz. Maybe time to wrap up.
Yeah, maybe. I don't know. Hopefully we didn't bore him, but it's near the top of the hour anyway. But I don't know. I've found this, even though we didn't have an agenda, fascinating talking to you as always.
Yeah, well, let's hope that people out there who have the time to listen to us banter are at least picking up something, and maybe if nothing else, it'll entice them to come to the next meeting and show us a thing or two.
Yeah. If anybody does pick this up, you're free as always to put your own items on the agenda. So this working group is always open to whatever. Okay, I'm going to stop the meeting, shut down the recording, but maybe I'll talk to you again in a couple of weeks in the U.S. series of the meetings. Good night, Hilton.
All right, night. See you later. And Moritz is back. See you later, Moritz.
Yeah, we're ending, Moritz.